Yeah.
So, what we're going to do is think about the properties of definite integral. First part you've seen a lot, I've shown you, but I still have to go through a few things. Second part, the sign area is slightly more difficult, but you need to think about how you could use these properties. So what we're looking at, the properties of integrals, the zero property, the negative property, the additivity, and the linearity. All right? Now, this is just a recall. You've got this, you don't have to write it down, and you've got it in your booklet as well. So we know the area. If we integrate the function of ft from a to x, we actually get the area function, right? That was the fundamental theorem of calculus. Now, so let's look at definite integral. What happens if there's an area at a point? All right? You can see that when area is at a point, that bit here, you're integrating from a to a. There is no movement at all, just that line. So in fact, we can say that the first property is a zero property. The area at a point is zero. So example, try using that example I have for you. Integrating from a to a x squared dx. What do you get? Why is it zero? You should be able to do it straight away, the integration. So x squared is pretty much x cubed over 3, correct? And you're integrating from a to a, and therefore you know that it's a cubed over 3. Take away a cubed over 3. Yeah? Which will give you 0. So the first one is a zero property. Area at a point is 0. Alright? Number 2, the order of bounds of integration. I showed you yesterday, if I integrate from a to b, it's actually the negative integration of b to a. Alright? So let's try evaluating 2 to minus 1, and then evaluate from minus 1 to 2. Start from 2 to minus 1 first.
Oh, wait.
Evaluate 2 to minus 1, x squared. So I'm using a lot of x squared because straight away you know it is x cubed over x cubed over 3.
Oh, yeah. You need it.
So can you start off with evaluating from 2 to minus 1? Let's do it this way. 2 to minus 1, x squared dx, and then 2 minus 1 to 2, x squared dx. Alright, you can put a negative in front if you like. And see what you get. So think about the interval. Where do you start, from A to B or B to A? Alright? So in this case, I'm saying that A is actually smaller than B. So if I go from B to A, I'm moving the other way. So the delta x is going to be negative rather than positive. Do you agree with my answer? I've got my answer here.
Yes.
Yeah? Alright. What if I do from minus 1 to 2? If I do minus 1 to 2 without the negative sign, minus 1 to 2, it's just basically that. Take away 1/3. It's plus 3. But if I put a negative in,
Negative. That's a negative here.
do you agree with my answer? Do you agree with the way I've done it?
Yeah.
So you can see that you can prove that, one, if you go from A to B, and then you integrate from B to A, it's actually negative A to B, that's all. That's another property. The third property, scalar. Shown this one to you before. If I've got a scalar property, k fx, just k times the integration of fx. We did that a couple of lessons ago, if you remember. So basically, you need to think about if you've got a multiplier a k multiple, it could be easier to do the integration of fx first and then multiply the multiply k in. This comes in really useful a little bit later when we look at sine area. All right. I'm not going to do physical area until next week, until after your test. But we're looking at sine area first. So this time I'm doing something slightly different. I'm going to use 2x squared. However, you do know that 2x squared, if I integrate 2x squared, I can actually integrate x squared and then multiply the function by 2. Correct?
Yeah.
Yeah? So, this is it, if I do it that way. But if I do it 2 times minus 1 to 1, x squared, I actually get the same answer as well.
Wow.
So, this situation, it really doesn't matter whether the 2 is there. But sometimes it pays for you to understand that because you might need to do this instead of that. Alright? You'll see it later. Why? That's a scalar multiple. Then the next is a sum of area. Again, I've shown that to you a couple of days ago. When you've got integrating fx plus gx, you could integrate fx and then integrate gx. Alright? So this, remember, when I showed you 2 days ago, when I moved the linear graph up and down. Alright? So if gx could be a linear, it could be something else. It really doesn't matter. Alright? In this case, where I'm showing you gx is just 4. So if you integrate 4, it's actually 4x, correct?
Yeah.
Yeah? So, you should get the same answer. I'm going a bit fast in this case because I know that I've been through this before. I want to go to the example first. I want to go to the example very quickly. So, if you can't remember that, actually refer back to what I've done a few days ago as well. Alright? This is just a slightly different graph. Again, what is done here is fx. If there's no gx there, that has been, fx has been actually moved all up. Alright? Translated up by gx in this case. One plus the other.
Yeah, you did. So
And then finally,
they did do it wrong.
the additivity, which means you can actually split. This one I have not shown you. What you can do is you will be able to split the integral into 2 areas. Alright? Sometimes you may want to do this first and then look at that. Alright? That is important for you to realize because we do have a situation where, later I'll show you again, something like this, where you've got this area and this area.
Yeah.
So we have to, if you're looking at the physical area, we need to find this area and this area. Alright? We'll talk about physical area in a few minutes. But here, just realize that when you evaluate A to B, A to C, you can actually split it from A to B and B to C. Alright? So, that's the example that I have for you.
Wow, that was really sped through that.
Alright? Now, important one for you to have that it's not in your formula sheet, but you don't really have to write it down in your notes. You should know all this. What is the area at a point? 0. Order of bounds of integration. A to B is minus B to A. Alright? Scalar multiple, k times fx, integrating kfx is k times the integral of fx. Sum of area, fx plus gx, you can integrate fx and then integrate gx. And then additivity means you can integrate from A. Integration from A to C is the same as integration of A to B and B to C. Now, you must realize that sometimes for this situation there, you could have integration of B to C is actually integration of A to C. Take away integration of A to B. All right? You can move around. Yeah. So this equals to that, take away that. Right? Yeah? So realize that that's quite important. I will show you an example in a few minutes. Now before that, try example 6 please. I've shown you all the answers. That's not good. Try example 6 first. I'm writing all the answers up because the iPad is playing out with my pen when I'm presenting the lesson, so it makes life a little bit easier that way. So look at example 6. You have to use all this information. All right, don't look at all this yet. So starting from the first one, this is just multiplying 4, that's all. Is that right? Because integrating from -2 to 3gx, if I use the scalar multiplication, I can take this one out to 3. So it's 3 times that. So it's 3 times 4. And then 5 times fx. Sorry, that should be an integral of -2 to 3. That should be an integral of -2 to 3. My fault. I will change that. -2 to 3. Because it's there. So it's 5 times 5. So therefore it's 12. Take away 35, which is -13. I did not type the question A properly.
No,
Where's
so I think
B?
you did.
Okay, you've got 0 to -2 and 3 to 0.
You're supposed to split it yourself.
It's 5, right?
Yeah. So straight away, you know that
That's 4.
is from -2 to 3.
Look, Max did it.
Additivity, which is 4. And finally, the very last one. See how I does it. The way I do it, I split that into 2. So I know this is one that you probably are not familiar with. Those are pretty much straightforward. This one, you've got to see that I am splitting that fx and then plus 3. So here, fx, I'm going to use this.
Huh?
3 to -2. This is -2 to 3. So therefore, that is -5, correct? Yeah?
Sure.
And here, if I
don't think it
integrate
needs
3
to
to
be in brackets.
-2, and that is 3, it's actually 3x.
Yeah, look at it.
And I don't actually have to change the bound. I can just use 3 to -2. That's fine. I still get the same answer, which is -6,
brackets, yeah.
take away 9. So therefore, it's -20. Got it? Okay? So using this is how you actually use all the properties. So the properties here is, I actually know that there's a change in bound, so it's negative. And
Okay.
that one, I can just integrate that way, that's all. Not an issue at all.
So I don't get it.
So integrating that way is just 3x. Integrating 3 is 3x.
But just say it louder for him.
Bottom just integrated, man.
All right, example 7.
This
Now,
one's actually killer.
this is a bit of a killer. This you would expect in an exam, I would say. Not that bad. Not that bad.
Not that bad, yeah.
It's not that bad.
It's not that bad.
I mean, look,
It's not that bad.
you know,
Do it then, mate. I bet you,
you
can't
know,
just
you know,
It's just
from 0 to 8. Alright? I'm lazy, I'm not writing all this now. It's actually
Can't
from
go that far.
0
It's
to
not that
3
possible. You have
and
to-
then plus 3 to 8.
It's not 8.
yeah,
Yes?
6 plus 2 is 8.
Got that? So you could, you know this, you know this, you don't know that.
No, but you got a 7 f of x.
0 3 is actually
different.
0 to 8 take away from 3 to 8. Yeah? See how I got this?
Yeah,
Negative 4.
25, man.
It's
Yeah.
not because it's
Because
7. It's not f
that's-
of x, right?
this is-
it's 7 f of x. Take one.
This bit here, I want this.
Oh, it's 4 times 7 then.
Oh my god, this guy.
Yeah, I think so.
I want 0 to 3.
7, it's not 25 then.
But I know from 0
we
to
got a
8
minus
is
to
0
1,
to
eh?
3 and 3 to 8. Yeah?
It's got a minus
Agree?
1 there.
0 to 8 is 0 to 3 plus 3 to 8. And therefore,
Oh, you were right.
0 to 3 is 0 to 8 take away
It's 24 minus 1.
3 to 8.
So it's 25. So it's negative 25. You get negative.
I got 25, but maybe I just brain
It's
dead.
negative. Yeah. This slows down. It's not going to
Yo! It's 28 minus 3.
What?
Which is,
Where'd you get 3 from?
because the bounds. The bounds.
Look at the bound, look at the bound, look at the interval. You really need to look at the intervals. The intervals are important. Alright? So the way I did it is I split it 0 to 3. Now,
Yeah.
because I split it to 0 to 3,
Hope they got it right. Hope they got it right. They didn't get it right.
I actually don't have to worry about anything else.
think you're
I
right.
can just integrate that.
Did he get it right?
That's all. I can integrate
It's
that
negative 2.
as x.
He got it wrong.
I got it wrong.
Yeah. It's
I actually got it wrong.
And
7
that's
times
how I
x
did it.
is
7,
6,
0 to
10
8.
Plus 3, it's
Take
59.
away 7, 8 to 3.
59, I think.
On moms.
Now,
Mom.
here,
Looking at that, I think I'm wrong.
you've got to change that. Remember, this is 8 to 3, so therefore it's minus. Yeah? Therefore it's minus.
I'm wrong.
Take away. See, that, I put this
Because
in a bracket.
3, that's not possible. So you're going to change it to 3 to 8.
Changes to 8, 3 to 8.
Which makes it positive. Oh,
Yeah.
2. No, so you're right. You're right.
Yes, I'm correct. That's why.
So
Yeah, so
therefore
that's a
is 7 times 4, 7 times minus 2.
Times 4.
Ooh.
6, not 4, 6, sorry, that's 7 times 6, 42 plus 14
No, no.
minus 3.
No, it's
53.
Is it?
What? So,
Hang on, I've done something
you're
wrong.
going definitely wrong somewhere.
I am wrong. No, it's right because here. Okay, all right. This is minus that, so that is 2. That should be plus 2. My fault. Minus 14. It's my fault. All right.
Minus 14 or plus 14?
Negative.
Like it's minus 14.
So it would be.
So here, this one here,
25.
I've already taken that.
I'm
That
still
is-
wrong as well, though.
I said
That is minus that. That should have been plus 2 because it's take away.
I'm right.
I'm already inverted that, so I shouldn't have done that. That should be plus 2. My fault. That should be plus 2.
Is it better to?
It's minus 14.
Look to the 6-mark question instead of 8.
All right. So I'm wrong there. It's my fault. I put an extra negative in.
So what's the answer?
It's on the
Whatever
board.
it is. 42 minus 17. 42 minus 17 is 25. Is that right? Yeah.
25? Let's go.
42
Hey,
minus
yo,
17 is
I'm
25.
28.
The whole thing wrong, but he got the right answer.
All right. Anyway, I made a mistake here. I made a mistake here. All right.
So can you redo it probably?
Sorry.
Can you redo it probably on the side?
Yep. So I've got 0 to 3, 7
No, I think
fx.
it's wrong.
Take away 1
Because it's actually negative x,
dx.
not negative.
All right. So I've got therefore this equals to 0 to
He
3,
pulled it out. He
7
pulled it out. He
fx.
pulled it out.
Take away dx. Take away 0 to 3, 1
Oh,
dx.
that makes it positive.
All right. So here, I know that 1
Yeah, no,
is
you're right.
0 to 8. Take away 3 to 8.
Yeah, you're right.
25?
0 to 8,
Oh, okay.
7 fx.
How do you get
Take
25?
away
No,
No, you did right. You did right. No, you did right.
3 to 8,
You guys just doubted me.
7
I
fx.
don't
You
doubt.
doubted yourself, man.
Yeah.
You doubted me. You said 8. You said 8. You not talking.
You said
Minus,
10 different
I'll
numbers.
straight away
Every
do
time
this.
instead of
X
different.
Check, that's your man.
0 to 3. Alright? So
I should've
now,
done an exam. Got
this
it
is
right.
7 times 0 to 8 is 7 times 6.
Yes, sir.
This is take away. Now 3 to 8, this is I've got to invert that.
Did you bring up
So it's 7 times 2
7
minus 3, which is 42. Take away 14, take away 3, which is 42, not 15, take away 17, which is 5, 25.
Woo!
Oh, baby.
That was pretty good.
Yeah, that's better. So I made a mistake here, I put an extra minus there.
Now we get to do signed area.
Oh, we have a whole. I don't know.
That was my fault, that was totally my fault. I will change that when I upload the slides, alright?
Yeah, yeah.
So I did plus here
Yeah?
because it was 3 at the top and 8 at the bottom.
Yes, you gotta reread.
Yeah, so it's plus
Even
2.
these two are in there, right?
So here that's plus 2, but you're going to take away that.
0
See,
to 8.
that's 0 to 8, take away 3 to 8.
What if I did 3 at the top and 8 at the bottom?
3 to 8.
Sorry?
Like,
I did it
like
easier way, but
in the question it says
Rearrange
3
that,
is
you
upper
get
bound.
3 is the upper bound, so you're going to change it to
8 to
negative.
0 minus your.
Oh, so you take it 2 as well.
Yeah, that's right.
That's why you get 8 0.
That because of the property of the indefinite integral. Alright, are you all okay with this so far?
8 to 3 to go 3.
If you are, take a break. We are going to take a well, I'm going to go straight. If not, it will take time for me to redo all the videos again. So we'll just keep going. All right, next one. Next lesson. This one leads straight to the next bit, which is the sine area. The sine area is basically pretty much think about what is positive, what's negative. All right?
Jump.
You are looking at the definite integral. So I would like you all to learn how to interpret the sine area function graphically using the fundamental theorem of calculus, and then solve sine area and physical area problems graphically and algebraically. Physical area, we will do it after the test. We don't have to worry too much about the physical area yet. Now, this one I showed you a few weeks ago, or a few days ago, not a few weeks ago. If I integrate from minus 2 to 2, I got a negative area, correct?
yes,
Can you do the next one?
it's the
Please.
same thing.
4 minus x squared.
It's the same thing.
If you do
It's 32 over
evaluate
3.
minus 2 to 2, 4 minus x squared, what do you get?
32 over 3.
It's 32 over 3, right?
Is it? I don't know.
Pretty much,
I should
it's just
see.
inverse of that. Now, I want you to compare these two.
Same thing.
They are the same.
But one's upside down.
But
Same
one is
area,
upside
same
down, that's
area.
correct.
Same area, but
So it's a sine
What's
area.
that
The
one?
word sine area is important. That is negative, that's positive.
it's control too hard.
Later, when you solve problems, you got to think about what is a negative area, what is a positive area. Alright? This stage, you need to think about the sine area. What is positive, what is negative. Alright? So, the area above the x-axis is positively sine area. Area below the x-axis is negatively sine area. Now, you've got to think about when you've got the area continuous, function where you've got area above and area below. You've got to actually think about which one is bigger than the other. Because by the time we solve problems, we need to think about looking at the area, the different areas and how we solve it. Alright? So, now let's consider this. I've given you fx as an example, which is sine 2x. So you know, because of the a and b is from minus pi over 2 to pi over 2, this area is actually the same as that area. Remember, your sine function is a wave function, and what is above, since I have not translated this up or down, the equilibrium is at 0. This area is actually the same as that area. Right? Agree with that? But if I move it down, this area will not be the same as that area. So the sine area is basically telling me this is positively signed, that's negatively signed. Alright? If we need physical area, talking about the actual area, if you need to sum the area, the physical area, then the negative sign has to be positive. We will work on that a little bit later. So, at the moment, think about the area above the x-axis as positive, below as negative. Alright? Now, from there, I've given you all the answer. You should be able to solve this. It's pretty straightforward.
Oh, so it's equal to 8, okay, cool.
So,
Would
what
the
A is actually 0, y.
Oh, yeah, that makes sense.
Is right at the point, correct? So I am integrating from 2 to 2. Gx is independent of everything else. Oh, I forgot to type the 8 in. Can you please put it in your book? Is equals to 8. Alright, it's equals to 8. So you can see that integrating from 2 to 2, same point, one straight line. The area is 0.
I thought we were doing sine thing.
The rest is basically using the idea that I've taught you just now. How you do that, and that. This one, 1 to 5, 1 to 5, 5 to 1 is
The opposite.
minus, negative of that, 1 to 5, the bounds. You're inverting the bound, therefore it's negative.
I can't see exactly.
3fx, fx is minus 4, 1fx is minus 4, 3 times the integral of fx is minus 12. Yeah? Now,
Half base times
5 to 2. Alright? You know that
This is nothing. You can't remember.
here,
You know your
this
base.
bit here,
You know your
you
height.
know that if I integrate
Yeah.
1 to 5, it's actually integrating 1 to 2 plus 2 to 5. Correct? Yeah? So therefore, I could use these two information to solve that.
But it's only one, eh?
Alright. So,
Area of a
I
triangle
want
is
2 to
basically
5
the right.
is therefore integrate 1 to 5,
that rule?
take away integrating 1 to 2.
Why are you making it so hard for
Correct?
yourself?
So integrating 1 to 5,
You draw-
It's
draw
6.
on here. Base
1 to
times
2
half
is
divided by two
minus
the
4.
area of that top triangle.
so it's 6 minus minus 4, which is 10.
Or you can just draw.
Think about it this way.
But what? No.
Alright?
You don't need right.
It's like your algebra.
It's a normal triangle, man.
This
Like
is
this.
very much so like an algebra. So
How you
you've
find
got to
the
be
area of
able
your
to
triangle
change
like
from one side to the other.
Half AB sine C.
Balancing the equation.
Half
It's the
base
algebra.
times height.
Here,
Perpendicular height. Yeah.
1 to 5, fx is 8, and that's 1 to, okay, that should be a bracket, 1 to 5. So it's 6 plus 8, which is
Sine
14.
theta equals
Alright.
perpendicular height.
If it's the base, then it's like this.
And then finally, that one is just minus 16
Just
because
invert
it's 4
You draw a
times
line here.
minus 4,
Your height.
and that's minus 24.
Wait,
Minus
so
8,
it's
that's minus 4.
Yeah.
Sorry?
It's
Half base times height.
Oh, it is 6, sorry, it's
I'm
my
very
fault.
disappointed in
It's
you
6.
not knowing that.
It's 1 to 5, not 1 to 2, it's 6. Sorry. It's 4 times 6 is 24.
That's one square.
No, it's not.
Alright, I got to change that.
Times half.
Alright, now let's come to the difficult one. Sort of. I want you to all concentrate on this because I'm going to go through this very carefully.
I can't
Here.
do it sometimes.
What sort of graph is this?
It is a Pythag. I mean, it's a triangle graph.
This wise, and you've got triangles,
3.
you've got trapezium, and you've got whatever.
You can make this a whole triangle.
Now,
All of this, a whole triangle.
we are looking at area.
Separating to this one.
Why?
Because I can.
Focus for a minute, please.
You don't need to.
I know it's late.
What do you have to do?
We're looking at the area, so we
Yeah,
know
you
that
know, right?
we have to think about all these points here.
Why you split it?
Where would it be triangle?
swing it?
Where would be
Make it three,
it be a
times
parallelogram? Or
Divide by
and what
two.
else? That's it.
We'll give you 3.
You've
Right?
got
Do it- do it
piecewise
again.
from
That's gonna be 2 and that's gonna be 1.
here to here.
That's 3.
Alright? You know there's a triangle,
That's right.
triangle, triangle, and then it's a rectangle.
What is the
Use
normal
your
of a triangle?
idea of areas to do the integration. You know integrating is actually,
Don't worry.
hey,
I probably understand, but I'm
Well-
just like retarded right now.
you know integrating is actually giving you the area under the graph, correct? So from 0 to 4, you've got a triangle 0 to 2,
Oh, that makes sense.
right? And then you've got a parallelogram from 2 to 4, or trapezium. Not parallelogram, it's a trapezium. All right? So you've got here, this triangle plus that. So can you work out the area of those two? You don't even have to integrate, just the area is 2 times, half of 2 times 2, and half of this plus this times the height,
It's 18, sir.
which is 10. 10.
You would.
Try the next one, please. Now, the next one, you are going from 4 to 7.
It's not 12.
This is positive, this is negative, correct? Up here is positive, down is negative.
8 to 7.
So you need to sort that out. Think about which one is positive, which one is negative.
12, isn't it?
Yeah?
It's 1.5.
Agree? Agree that the top bit is
No,
positive.
'cause we've done it.
That is triangle, that's triangle. You can use your triangle formula.
1.5.
So it's half times 2 by 2.
Negative 1.
So the thing is, the way I answer this question is I quickly glance through all this and then I write down all my points so that it makes life easy for me. If you know the points, you can straight away work out the vertical height and the horizontal height, right? Yeah? So it makes life a little bit easier if you do it that way. Always write down the points. What I do is I quickly go through, I just have a look at this. I know that I need a point at 4. I know I need a point at 7, 8. I need a point at 2 and 10. So quickly I wrote all this down on my graph. So that I don't actually have to, when I answer this question, refer back to the graph again. Technique of answering questions. Make sure that you label your graph. So you now know you've got a big triangle and small triangle. That's your answer. And finally,
8, take 2 to
when you've got 2 to 10, 2 to 10,
2 units square.
here this is positive, and this is negative.
2, I think.
All right? So you need a big triangle, take away a
got 2.
trapezium. Here is this plus this times that, half of that. All right? You should be familiar with the formula.
Why is that?
And of course, I get the answer as 2. Agree?
Yep.
All right. Let's go to example. Which example? Example 3, please. Sine area example 3.
Yeah, but
Now, example 3,
but like that, they give you.
you're given the area already. So you know the area from -4 to -1, -1 to 3, and 3 to 4. All right? You know there's 7 centimeters square, there's 14 centimeters square, there's 5 centimeters square. If I want to do from -4 to 4, all right? Definite integral -4 to 4. Plus area, minus area, and plus area. Correct? Is 7 minus 14 plus 5. Yeah? Agree?
Yeah.
Yeah? So that would be 7 plus 5, positive, that's 12, and negative 14, which is 2, minus 2. And of course, I've forgotten the area units. It's -2 centimeters square. Totally my fault.
So on the last question, do you have to put units squared there? Or
No, you're evaluating the definite integral.
okay.
You're not really evaluating the area. It's just
So
the
we only have to give units if it specifically says evaluate the area. Okay.
All right. Now, what? Okay. here, actually, no. Here it says that it's definite integral, so I don't even have to know the area. I have to write down the units of the area because it's definite integral. It says here it's definite integral.
Oh,
What do you
okay.
mean?
But it's weird that it says centimeters on the graph.
Yeah, that's right. Doesn't matter. So you are using that to evaluate the definite integral. So minus 1 to 4.
Yeah.
It said like
You are
determine the value.
going from here to here, so therefore it's negative from minus 4 to 1, correct?
Squared, which is centimeters squared.
Yeah.
Whatever.
See,
Yeah.
this area here is from minus 1 to 4.
What did you get for C?
Remember, the area that's drawn on the graph is always from left to right. Left to right, left to right. So therefore, I want
-7.
the inverse of that. Sorry, the negative of that.
Probably it's a dumb mistake there.
So therefore, it is minus 7
24.
centimeters squared.
Yeah, I think I'm wrong.
Yeah? Got it? You need to know how to interpret that. Therefore, I'm going to suggest you, when you do questions like this, Club 4C, which I've uploaded, that is a really good
Yeah, I was doing
exercise
that
like that.
yesterday, yeah.
All right. The next one, minus 1, from minus 1 to 4. So, you basically wanted this,
So
you
it's
want
something else.
to look at this area.
So different.
Yeah.
Minus 1 to 4. All right.
I got 28.
Yeah? So you know that this bit is minus 14, this plus 5. 2 minus 2fx. So I'm going to split that into integrating minus 1 to 4 for 2. Because that would be, if I integrate minus 1 to 4, 2 dx, that is minus 1 to 4, 2x, 4 and minus 1. Alright? That is how I would do it. I will split that. I will split that. Once I split that, I now have, well, the other thing that I did was I actually took the 2 out as well. Because that is the multiplier. I took the 2 out. It doesn't matter if you did not take the 2 out, you still get the same answer. It's up to you. I took the 2 out. And therefore, I can do it this way. It really doesn't matter whether it's 2's out there or it. Then you can work on that between 1 and 4. Minus 1 and 4. So integrating 1 gives you x, correct? Integrating fx from minus 1 to 4 is 14. Minus 14 plus 5. And therefore, you've got 28.
Yeah, I got it right. I got it, but different way to him. Well, I didn't sub out the 2, but it's still the same thing. See, I just did like
Alright, happy with it?
split it.
The hardest example is the last example.
-2 times 5 take.
Alright, example 4.
It's 5 take away.
I've got 2 more examples to
14
go.
on the bottom and 5's on the top.
Yep.
1.
Alright, focus please. You'll be expected to know something like example 4 and 5 for the test, alright? Let's have a look at here. 4, pay attention. Now, the sine area function A is such that AX is integrating from 0 to x
Actual
ft.
answer for that.
Alright? You know that if I integrate
I don't know where you 8 plus 2 is equal to
whatever you call it, this function, it gives you the function of AX, all right, which is the area. So from 0 to x, let's think about how we're going to get A3,
0 to 3.
all right? So you have x is now 0. Sorry, it's now 3.
Negative.
So you integrate from 0 to 3 ft times dt, and what is it? That's the area.
Should be
Area between 0 and 3. This is 3 here, 0 and
I
3.
would get the negative of it.
It's a triangle, correct? That is part A, A3. Think about it as area now. Area. Agree with me? So A8, what happened? Where's 8? 8 is here. What is the area? you've got this area to be included as well. Correct? Yeah. Part 2, A, 8, you've got that area to be included as well.
2. Oh,
So-
pop test.
A8,
3.
integrating from that. So 0 to 3, you know that's minus 9/2, and 3 to 5. If you work out the area, the sum is 3. Now, do a sanity check. You know that this area is actually bigger than that area, because this is drawn to scale now. So therefore, if you get negative, something's wrong. It has to be positive. This area is bigger than the area. Now, part 3 is the interesting one. Can you all focus for a minute, please? It says here the values for which AX is greater than 0, which means the area is actually greater than 0. Right? Now, let's have a look. Here, the area is less than 0, correct? Now, if I keep on going,
6.
up to where?
6.
This area, all right, this area here, and which area
6.
between here and here, it will balance out, correct?
Yeah.
Which means it's 0. Yeah? All right. So, if that's 0, anything that's above will be positive.
Yeah, but isn't there also
Agree?
10?
Not yet, not yet, not yet. So it'll be positive until you get to here. All right, you need to think about this area here. And where does it go until this area becomes 0 again?
10.
Yeah? You see that
Okay, don't go.
with the graph. You can actually tell this bit here, this area here is the same as this area here. Correct? So, anything smaller than this area, this bit is greater than that. So, area above AX equals to 0, that implies that, hang on, what have I done there? That implies that, area above the area, equals to 0. AX, when area above X is the same as area above X axis is the same as area below X, below Y axis. So therefore it's between X and 10. Now, the other one that you need to know, at the start, this is a tricky one. Because at the start here, at this point, area is 0 as well. Correct? Yeah?
Yeah.
Remember, area at the single point 0. There's no area, but the area is negative, 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 and then positive. Alright? Positive, positive, and then negative. Agree?
What do you do with the DDX again?
Now, just a note for you.
8 to 0.
8 0 and then I'm
Okay.
2 0.
Just a note for you.
2 0.
See, this is what I've shown.
Wait, so
0 to 6
8 0.
is 0, because that and that is 0.
and below that is
10 to 6,
2 0.
6 to 10, that's 0. And then finally, that bit at this point is 0. So the value is when, sorry,
It's
the
0 to
value
0
at
to
this
2.
point, area equals to 0. Value at this point, area equals to 0, because this and this ends up to be 0. And then here, this and this add up to be 0. So it's 6, 10, and 0.
Yeah.
All right?
0 to 2 here.
This is important for you to know because it will link to later.
Then it wouldn't be.
Now, for AX greater than 0, the area of X greater than 0. Now, the total area here must therefore be greater than the total area under the graph.
It means
Correct?
A dash X.
Here, there is a definite point. The interval is between
Add AX.
0 and 14. Nothing greater. Nothing else.
Yeah.
All right? So you're only considering this
What do you
area,
get?
this area, and this area. All right. So you want to know
We did it
that
yesterday,
when
but I wasn't
AX is
sure.
greater than 0, is when the area above the
I
x-axis
literally
is
forgot.
actually greater than the area below
Yeah, I know
your
it's just way
x-axis.
better as well.
the area below the x-axis. So if I move across,
Because that's just equal to f x, so you just chuck the x.
if I move across,
Yeah.
I know that this point here, this area, is the same as this area. Correct? So therefore, at this point onwards, the area will be greater than 0. Alright? Greater than 0. Okay, I keep going. Here, the area is still greater than 0 until you get to very close to 10. At 10, it becomes 0. Correct? So therefore, for the area to be 0, it must not include x equals to 6 and x equals to 10 because there's a point area equals to 0. Can you see that? Can you see that it's moving across? That area is actually positive, positive, positive. I know it's getting smaller, but it's still positive.
This
And
big
then
F is like
it's
x
still positive because
Subtract
this
the x.
area is smaller than that area. So if you
It's
take
more
this bit
diameter.
here at 7,
Yeah.
this
So
area
it stays as
is
fx.
still greater than that area.
Yeah,
Correct?
That's true.
Yeah?
Yeah.
Yeah?
But then when you put
So you
one,
keep going until you
Yeah,
see
negative.
the point
Yeah.
where the area equals to 0. So therefore, in this case, it's 6, between 6 and 10. You cannot include 6 because area equals to 0 here,
Because
area
Oh,
equals to
yeah.
0 here. You want it to be greater than 0. Alright? And finally, determine an expression for ax, and hence state the value of a dash 1. Alright? So we know that using your fundamental theorem, ax equals to d x 0 to x ft dt. Alright? So therefore that becomes fx. Correct? Using your fundamental theorem. Fundamental theorem of calculus. Part 2, part 1 of that, d dx of that becomes fx. So therefore, f1, what is f1? Look at f1. f1 is minus 2. So that's it. So that you can refer to the graph in this case.
Yeah, man.
Alright, now next bit is important. You've got your graph in front of you. What I want you to think about is when we look at this, this is function ax. Alright? Ax is whatever. That. Now, we know that fx here is actually the gradient of the area function. Agree? All agree? So fx there is the area of gradient function. The next bit is asking you how to plot. So what you need to think about is, let's start at the roots. Roots is when ax equals to 0. So you've got 3 roots there, where the area is 0. So you know the 3 points. Straight away you can plot the 3 points down. Ax equals
Wait,
to
so
0.
is this sketch a dash x or ax?
Ax. Ax. The roots. Alright? And then the next bit, look at the global maximum. Global maximum happens when x equals to 8. Go back to your graph. Think about your graph. Think about your graph. Oops, sorry, wrong one. Look at your graph. Alright? Maximum. Alright, this and this is 0. Correct? The area and this area added up is 0. Correct? So it will go on until maximum is here. Here, anything
Yeah.
going towards there, it will become less. Alright, so the maximum is at this point, the area maximum. Think about area, not the graph, the area. Negative area, positive area. Here, all the way up to there is 0. Area. So therefore, there's a root, and root there. Yeah? The area. So the area here is 0, area here is 0, area here is 0. So the roots. Negative, positive, all right? But at this point it cancels out, so the maximum is at 8. So if the maximum is at 8, we can draw that. 8, 3, I forgot. Oh, I did draw 8, 3. So 8, 3 is there, all right? So therefore, we know that. Then we look at the global minimum. The global minimum is actually right at that point, the last bit. Have a look at the graph again. Up to here, 0. Up to here is 0. So therefore, the minimum is there. Correct? Because area is 0 here. Think about area function. Area 0 here, area 0 here, area 0 here. So anything of that is negative. So you have, therefore, that negative. Work that out. A8 minus half the area is minus 14 minus 12. And then local minimum, back to this. Local minimum is at this point. Alright, there's maximum, but there's local minimum here. You go up, negative, 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 minimum, and then you start positive again. So that's local minimum. So you can work that out. You have already worked that out. So therefore, that is 3 and minus 9 over 2. Alright? So you've got to think about this. What I'm going to do is, I'm not going to do example 5 until tomorrow.
I reckon I got it.
Alright, I will upload the solution for example 5.
Everything here.
We'll do it tomorrow first thing in the morning when I see you.
If you go like one here, you only have to go.
Alright, here you can see that the function goes from here, negative infinity to positive infinity. Sometimes when you do the integration, there is a fixed number. Alright, for example, the one that we did yesterday, on example 4, we are fixing it from 0 to fx. Alright, I'll come back to that in a few minutes. So let's say I am going to fix it from here. Alright, this point onwards. So when I integrate, that is 2 pi minus 2 pi to x, all the way to x. So the limit is that we are not going to go beyond 2 pi. Sometimes you don't have to think about anything behind that. Alright, sometimes you do. The last example I will show you will need to think about that. Here, if I start from 2 pi, if I want to show you the area, just pay attention to the area. If I go onto the area, if I go from minus 2 pi to pi, alright, that will give you the area of 1, for example. That's the case. We're going from 2 pi onwards. Then if I do minus 2 pi, oops, this is going
just
to,
pi, so.
alright, hang on, let me get rid of that first.
So is that minus 2 pi or just minus pi?
Minus, oh sorry, minus pi, not minus 2 pi. Minus pi. Not 2 pi, 2 pi is here, minus pi. Alright, minus pi onwards. So, if you look at from minus pi, just let me show you minus pi all the way to somewhere here. 1. You can see that the area is still positive because
You can't count
the
it
area
out.
here, this is positive area, is bigger than that area. Yeah? Now, what if I go on?
So
This
zero.
is a really good illustration.
It is a very good.
Okay, let me get rid of that. If I keep going and going all the way up to here, would it be positive, negative, the total area?
Positive.
Positive, because you can see that I am
It's not too bad.
doing
Yeah, I didn't really know.
integration from
Yeah, shut up, mate.
there all the way up to that bit. So it's actually positive area. What else can I show you? You need to be able to think about your area function, alright? From here, if I go, let's say just from 2, minus 2 onwards, that is positive.
Yeah. It's zero.
This is the point at some stage, it will become, or the area is 0.4154. So if I go back a little bit more, this is where it's hard for me to mark around with this, but you can see that if you've got the area above and the area below the same, you got 0 area, right? So this is actually quite a good illustration in that sense. Let's get rid of that. If I start from here, this is positive, and then I go back to positive area, negative area, keep going, negative area until, the area, net area is still positive. Until there, there'll be 0.
Yeah, which is that.
Back to positive again,
Oh.
Yeah, so it used to be the graph.
back to positive again, and then negative again, and then net area will be 0.
Yeah,
So
here
this
it's
is just a
negative.
sign area. If you talk about physical area, you need to add all of them together, which is 4 of this green bit. Alright, let's go and have a look at this question now. So example 4 from yesterday. You don't have to consider anything below 0. X below 0, we are not to worry. We are going to worry about from this point 0 to 14 only. Now, if I go to example 5, example 5. All right, here, watch. The question is, when you look at the graph, you've got somewhere from minus infinity to positive infinity. However, here is telling you that I'm going to start off with minus 6. So anything up before minus 6, let's ignore it. That is the point that we are starting. All right? So this is it. The limit here, lower limit, lower bound tells me that I'm starting with minus 6. Any area before that, ignore.
Ooh, 3.
All right? So therefore, we're going to start off thinking about the values of k such that that equals to 0. First one you need to think about is this point here. All right? First point, that bit, the area is 0. Remember? Area at one single point is 0. So the first k would be 0. All right? At minus 6. All right, x is minus 6. Sorry, not k minus 6. So you need to work out what k is. K is minus 6 because you're going from 6 minus 6 to minus 6. So therefore k is minus 6. All right? Then you slowly move across. Move across until such a point that this area and this area is the same, correct? Yeah? So you know that, and then you're going to go somewhere around which is the
It's going to be
same.
10.
So work the area out. So minus 6 to minus 4, the area is 3 over 2.
Oh yeah, true.
Shouldn't,
Yeah?
shouldn't it be?
So you work that out based on the area of the, using the
Maybe.
formula of the area of the trapezium, or trapezoid. Now here,
Is that
you know that this is 1.
and then
But this
all the way
one
to
is
here.
not to 1, so therefore you cannot stop there. You need to think about the area k. As such, this area is the same as that area.
K value. That's
Right? So how do you work that out? Again, you are going to
This is
integrate from minus 4 to k, and then the answer is going to be minus 3 over 2. Minus 3 over 2. All right. Now, write this out. You know this fx. This is actually x minus 4. You're expected to be able to do that. Mx plus c. Yeah? So you know this function here is minus x minus 4. And you can do an integration. How do I do this? All right, I will show you how to use class fact. This is the one that's important. Minus 4k minus x minus 4 dx equals to minus 3 over 2.
Oh, you're so
now,
smart.
you've got to be really careful when you use solve. Where's my class fact simulator? Class fact simulator is here. All right,
Class simulator.
go to
Class simulator.
go to your keyboard and
the
math
line.
2.
The line you got. This is negative x.
This one.
Minus 4.
Now,
If you extend it, you go.
you've got to be very careful.
part of the line.
Oh, actually, I cannot use that. I need to start off with solve first.
This
All right.
looks like an actual
I need to
class
use
fact.
solve,
smart.
the solve function. you need to solve for k, correct?
Yeah.
You
Oh,
want to
mate.
integrate that, but solve for k.
Doesn't that cost money?
So
It's free.
solve.
It's free. Trust me.
From there, go to solve,
You just don't get everything.
and then you do your integration.
Like, you don't get all.
Make sure that you do not type x in here. If you type x in here, it will not be able to solve it. All right? You can use y and dy, doesn't matter, as long as this and this is different. On your class back, you've got x, y, and z. So I might just use y up there, y, and 0.
Oh, you don't get integrals. They don't give you
Is it
integrals.
oh no, minus 4, not 0. Minus 4.
But you
And
don't get
then
the
type
integral.
in
You don't even get integrals, bro. What?
minus x
Oh,
minus 4 dx.
No, okay, I'm not
Alright?
doing
You want to solve for y, so put a comma and type in y.
Oh, you don't
And
even get.
oops.
You don't get complex numbers.
I know y. Bracket, comma y.
Delete
Something's
doesn't
not
work.
right.
I think
Oh, my class. my class bed broke.
Wrong argument type. Yeah, I forgot. The negative equals to negative 3 over 2. Of course. Still giving me that error.
brackets at the end.
That
Do I need a
doesn't-
bracket there?
Maybe.
Maybe I need a bracket there.
No, it's not that. Now you got too many.
Let me have a look at how I did it.
My class.
So you don't even need to use this. You can just use area formula.
You can use the area formula if you want to, but I'm just
Yeah.
going to show you just in case you don't have the whatever, that's all. Let me have a quick
Well, my
look. what I've
calculator
done.
broke.
You also have class with simulator.
Yeah, let me check what
Yeah,
I've
but
done there. I have
What
typed
the
in
fuck
something
is wrong with my
incorrect.
class bed, bro?
Oh my.
You need to be able to use this because sometimes you don't have you have x squared and x cubed, that sort of stuff. So you probably it's a
better
good
one.
idea to do that.
Shit, man. Wait, so B squared is 16 minus 4.
I don't even need that.
No, well, you got this one.
Okay, let's start again. So I'm going to solve for x. Let's go for
But I'll show you later.
that
So,
Brain dead.
minus 4
Okay, yeah, brain dead.
to, let's say, y. And this is minus x minus 4 dx
scientific
Alright.
calculator.
Two of the top three cards.
equals to minus 3 over 2.
All of that just
Why is it doing that to me?
You don't even get into
Mr. money making at the rest. After shooting like 15 million free throws.
X equals -6 plus 7.
If any cringe. It actually did.
So K.
Alright, I will find out what's wrong with what I'm doing there because I am not getting the right answer. The right answer is something like this. This is what we're supposed to be able to get. I'm not sure what I've done wrong there, but this is what we're supposed to get. Yeah, I've tried.
I'm not gonna get my
Yeah, that's what I put in. No idea
You sure?
why.
You sure you put in?
You put in the brackets on the answer.
Yeah, you don't put the
Yeah,
bracket at the
it-
very end. At the very end, sir.
Yeah, I did.
What did you?
It's still not giving me the right answer.
I don't think you did.
Are you in radians and that?
Yeah,
Okay.
yeah, I will check.
Play CSGO too.
Nah, doesn't
Yes,
matter.
but
But this is you've got the
Is it
idea,
good?
all right? This is what we need to put in. I will check where I went wrong. Not now.
Let's play.
I'll do it a little bit later.
So
when I
can you
finish
use
my
the?
lesson.
Can you show us how to do the area formula one as well? Or the?
Which one?
What are we trying to find here with that?
What are we trying to find here with this?
We're trying to find
Area under.
So back
we
to
have
this
this
one.
area
Let's
here.
go back to
Yeah.
your.
We want to find when
that's
this
like-
triangle. We're increasing the x here.
All right,
So
hang in there.
when this
We'll sort this
triangle
out a little bit
has
later.
an area,
Let me explain the procedure how to get it first.
then we can
So
get
now, listen.
this length here
You
using-
solve this and you can get that area equals to that. K is minus 2.27. All right. That means this area and that area is 0. Correct? Agree? So next bit, we need to think about part 3. Part 3, I've marked K here. So I want to find this area and this area from here all the way to here is 0. You already know that 0, but you need this area and you need this area, you need to work this one out. So what you could do, this area, you know this and you know this area. That you can use your trapezoid area from up there anyway. Here you can use the trapezoid area as well. So you can work it out from minus 1 to 4, minus 4 to 1. You can work out the area. You don't even need this. You work out this area minus 4 to 1 is minus 7. Minus 7 take away 3 over 2 is minus 11 over 2. Alright? So you know this area. These two area added is the big one. So you know this one, you can know the green. So you know this green has to be the same area as that. Alright? Here you can work out a triangle, correct? Because here this area and that area added up will be 0. If you look at this carefully, this area and this area added up will be 0. Correct? All you need is this area, which is a square, is the same as that area.
Yeah.
Yeah? So do that. So you know that's K minus 2, that's 2. Again, area, you know that for this area, take away the triangle, which is 9 over 2, and therefore K minus 2 times K is minus 2. What's wrong with that? I have no idea. K minus 2 times 2 is 9 over 2. That is this bit, this area here and that area there. Alright? And then you can solve for K. So there are 3 values of K.
Yeah, okay. No, sorry.
I've got too many things on. So. Alright, so you've got 2 values of K. And can you work out K to be 4.75?
Yeah.
That point there. Right. Then let this be capital Fx equals to minus 6 to x, integrating from minus 6 to x ft, determine the minimum and the maximum value of fx. So you know the minimum value of x equals to 1, because here, this is, everything else is positive. This is the only negative bit. Yeah? Have a look at this diagram here. This bit here, this is the only negative. The rest is positive. Right? Agree? Every other area is positive. Up there, positive. This is the only negative. And we are only considering from 6 onwards. Yeah? So we know that from here to here is 0. And then this is all negative until here. There's a minimum. Agree? Yeah? See that? So here, we don't have to worry about this area here now. Because that's 0. Net area is 0. So this is negative, and you keep going negative, negative until that's the minimum before it starts going back to positive. Right? So therefore, you can work out from minus 6 to 1.
Max is infinite.
And you can work out that would be minus 11 over 2. Now here, the bound, upper bound is important. There's a stop here, there's a limit here.
Because the arrow.
So we don't have to worry about anything before that. But the arrow is telling you that it's going on and on and on and on and on.
Yeah.
Which means as this is going,
Yeah.
to infinity, the area will be going to infinity as well.
Yeah.
And therefore, there's no maximum for the area.
Okay.
There's no maximum because of this arrow here.
Yeah.
Got it? Yeah.
Yep.
Unless there is some way to stop it, then there's a maximum. If not, the arrow here is just telling me that's going on to infinity.
Huh?
Okay? All right, I'm going to stop here. I'm going to stop the recording.